Hello everybody, this is another video. It's not a live stream, but if I was more popular, it would be. Bitcoin Dev Kit in Rust. So if you're not interested in Bitcoin, you can still pick out things from this and apply it to your Rust code in general. There's specific things which you will only come across in Bitcoin, such as your transactions and your public-private keys, so on. But hopefully you'll get the idea and maybe pick up some new kind of ideas or inspiration. I've documented all of what I've done on my website, and let me just find you the post. So what this is going to do is create a wallet. If you don't know what a wallet is, it's what you need to be able to create a public and a private key, and that is basically what controls your access. Private key means only you can access the funds on the blockchain, Bitcoin blockchain. Create a transaction. So effectively that is you transferring some funds from, if you imagine it in a traditional bank account, you're sending it from your bank account to someone else's. It doesn't actually work that way. All you're really doing is changing the ownership of some Satoshis on the blockchain. They don't actually move. You're just changing the potential ownership. They stay yours until transaction's gone through. Sign a transaction. So once you've created it, you have to sign it, and then you broadcast it to the network. I'm not going to get into specifics of that here. I'm really going to actually just demonstrate the code, and this is going to be more practical. If anybody's watching this and they're very familiar with BDK, and I've said any errors or anything, please add in the comments, because I'm self-taught. I've read the documentation. I've done some experiments. I've used BDK. I've used Rust, and I'm still learning both of those. So one thing to notice is I'm using the testnet, so it's not the Bitcoin network that contains funds which are convertible into legacy fiat money as we know it. Here, I was doing a test and had output below dust limit. Dust limit is when the amount of Satoshis is less than actually the fees that you would incur to make the transaction. Miners need a very small proportion of your transaction to stay in business. Obviously, they've got costs. They're doing the mining, lots and lots of computations to come up with a hash which satisfies the current difficulty. So we need to get more sats. So I've put the link here, and that takes us to something called the test faucet, Bitcoin Testnet Faucet. Faucet, if you don't know, is like a tap, I believe. It's a word I don't come across much in England or English. I think it's probably more familiar to Americans. If you're in America, is faucet a common word? It's not in the UK. Anyway, Bitcoin testnet address. So what we do is we send, this is the amount of Satoshis, or the amount of Bitcoin actually, sorry, that we're going to send to our address, our test address. And then we will have those funds available to spend from our wallet. We're going to create a wallet with the code. So let's just go look at the code and we'll come back to that. So I hope that's okay to read. I don't want to make it too big because otherwise everything goes off the right hand side. So you can see I've done all the BDK imports. If you've seen my previous videos, you will have probably already seen a lot of this. So I'm going to skip to the bits which I've recently modified. And this is I'm hard coding a lot of this just for testing purposes, and obviously then I will then go and refactor this to create separate functions. I don't know how much I can do that with my level of skill, but we'll see. I'm using the electrum Electrum for my client. So that's actually what enables me to talk to the test network and create a wallet. I create a wallet based on the blockchain, and the blockchain references the Electrum, the Blockstream Electrum server. So I create a client, the client becomes part of that blockchain, and then the blockchain gets used to sync the wallet. So my wallet that I create with my code then syncs with a real Blockstream Electrum server, which queries the real testnet blockchain. So although this is not real funds, it's the Bitcoin. It is the real Bitcoin test network that we're using. I've specified that here on that line. You see, the memory database. For this, I'm using the database is memory, so everything's held in memory. There is something called SLED, and you can also use SQLite. I'm not worrying about that for now. The purpose of this video is to experiment with receiving funds to a wallet which I create. Once those funds are in my wallet, then further down we will create the transaction. We will sign the transaction. So we sign the transaction here, wallet.sign. So there we see wallet.sync, and we get the balance. In the BDK example, you may see that they use balance divided by 2. But obviously, if you're doing that, then you are sending an unknown amount, potentially large amount, which you would not really do in practice. So I've hard coded the amount here, and as you saw in my article, if you send less than 546 satoshis, or sats, you'll get the dust error. So when you get your sats from the test faucet, that's why it's this number here. That actually converts to 1000. Don't quote me on that, but it works, or it did work. If I run it again, I don't know what's going to happen. So this has got an element. This is kind of like live coding, but by the time you see it, it's not, if that makes sense. That print message is just, that gives the Blockstream website address for testnet, and then you can actually check for confirmations of your transaction. So everything here is a true replica of the active Bitcoin mainnet network, but it is just the testnet network. Okay, so let's exit that. The first thing I need to do, so I've already spent some of those doing my first test. So actually, I need to get that address again. No, I don't. I need to know what my generated address is. When I run this code, so let's run it. When I run this code, it creates a generated address, but the generated address is the same each time. And that is because I've used it's called a wallet descriptor. So up here, and because that's hard coded, I get the same generated address each time. That's how I understand it. If anyone's watching and that's wrong, please comment. So if I run this, it will give me a generated address, and it might fail because I've got insufficient funds, but that doesn't matter because I'm running this to retrieve my generated address so that I can then send some funds to it, and then hopefully it will work the second time. So yeah, that is the address that I'm familiar with. I'm expecting the actual transaction to fail because I've got insufficient funds, yeah. So based on the current fees, I'm trying to send. So don't be overly concerned about this. The fees are 110. So as a percentage, that's 110 out of 1,000. So what's that? 11%. So that you'd think that is a massive amount, but the fees don't go up pro rata. So you could send a huge amount of Bitcoin, and the fees are very insignificant. Unlike the Visa network, for instance, or Western Union. Okay, so now I've got my generated address, which is the same every time I run this code because I've used a wallet descriptor. The wallet descriptor you can actually get from the Bitcoin Dev Kit if you go in the documentation. I'm trying not to digress too much here, but the descriptors, if you go, if you read about, go to the tutorials. So if you go to tutorials, Bitcoin wallet, one of the tutorials will give you, there you go, you can copy it, there you go. So you can copy and paste that descriptor into your code, and that will generate you the wallet address, which will be the same each time. So back to the faucet, and I'm going to paste in my address. When you paste it in, just make sure there's not a full stop on the end. I copied and pasted from somewhere when I was testing, and I ended up with a full stop. Right, okay, let's send. So we're going to send from the Bitcoin Testnet blockchain out in the shining city in cyberspace. Let's send that. And it's going to be allocated to my wallet address. Once it's allocated to my wallet address, I will then be able to create a transaction within my wallet. So all this is unique to my wallet. Only my wallet will be able to spend this this balance. So up here you can see current wallet balance 5432. You can get up to. That's not relevant. That's not particular to me. So there you can see that was the transaction which sent to me because my ends in QGHN. Just pending. Let's open that. I think this will take me to the Blockstream Block Explorer. No? Oh, Brave's trying to look after me. Let's try again. Okay, don't worry about that. We appear to be going around in circles. Right, okay, let's actually test the code then. So I've still got that generated address. That will be the same next time. Let's just run it and then I'll talk through it because probably you're bored of me talking. It takes a few seconds because it needs to query the Blockstream Electrum server to get the balance. Once it knows the balance is sufficient, then it can successfully run the code. So let's read through this. I'll just make this slightly larger to read. So the generated address, I've talked to death already. The wallet balance in sat, so that's Satoshis, which are, is it 10 to the 8 Satoshis in one Bitcoin? There's lots. Untrusted pending. So that is the amount which in my code, we'll go back and look at it in a second. That's what I'm sending. So I'm sending 1,000 back. Confirmed 357. 357. So that's the fee by the look of it. You see 357 there. So although I was effectively paying 1,000, The fee was another 357 sats. As I say, the fees are kind of semi-fixed, so even if whether you send a small amount or an enormous amount, the fees don't increase proportionally. So transaction ID received. Because I was spending all of it, I didn't set a receive address to receive any change. I'll go on to, I think I need to look at that next, because obviously that's the logical next step, is to send some funds and then receive some change. Let's just look at the transaction if Brave will let us. Overpaying. Yeah. The reason we're overpaying is because we're sending such a small amount. Obviously, even with a small amount, the fees are still pretty much the same. So yeah, there we go. It's on Blockstream. Unconfirmed, obviously it take another 10 minutes and then another 10 minutes and so on with more and more confirmations. That's perfectly normal. When you buy or sell your first lot of Bitcoin, you will have kind of 10 minutes of biting your fingernails, but after a few times you know that that's standard and it's nothing to worry about. I would say after 10 minutes, you know it's okay. After half an hour, you know it's really okay, and after an hour, you know it's definitely okay. The chances of kind of it being modified, should we say, decline every approximately every 10 minutes with each new block on top, with the Merkle tree being recalculated and so on. Okay, so that code worked. Let's go back to my website. That was when I did a test earlier. The transaction was successful. So yeah, as you can see, this is just a screenshot, which will be here for you to look at. I'll talk about the actual GitHub repo in a minute. So that was 1,000. Fees were big compared to the amount because the amount was so minuscule. But as the amount grows, the fees don't increase proportionally. So we created the transaction and then we signed it here. Sign. This variable here, so the PSBT is partially signed Bitcoin transaction. You see it's ampersand mut. It's mutable and it's a reference. So we created PSBT. Where did we create that? Higher up. It's not on here. So my next step is to create a change address as well. As I say, there are some defaults with BDK, and I can't remember whether the change address is the default or not having a change address, and it just spends all of it. I think it spends all of it by default. So if you want some change, you will need to create a change address. That's one of the things with Bitcoin is if you send the whole amount, the code thinks that any difference between the unspent transactions that you're sending um, and the amount that you're specifying in your code, it thinks the difference is basically the miner's fee. So if you don't specify a change amount, the miner pockets the change. So yeah, just bear that in mind. That's really important. If you've read Anton Antonopoulos' book, you'll cover that. So code, I'll just quickly cover that and sign off because there's the code that is passing, which is nice. Creates a wallet, creates a transaction, signs a transaction, broadcasts. So I've successfully proved that I can test Bitcoin from the faucet. What's not allowed here? I don't know what that is. So you get some fake. It's not fake. It's real, but it's real. It's test Satoshis. Yeah, I won't waffle. So that's Bitcoin Dev Kit. most of the code came from here, but then I started modifying it because the test amount was here, which I found this curious, to be honest. It was just takes the balance, it takes the balance trusted pending and balance confirmed. So basically, that's what you've got confirmed in your wallet, plus anything that is kind of incoming and being added to it, but it's trusted. I'd need to look up the definition of trusted. Presumably, that's a certain number of transactions have already elapsed, so it's now trusted. But it's just dividing that by 2, so basically it's spending half of what you've got in your wallet, which is fine. But if you've only got a really small amount in your wallet, then that will be insufficient because of dust, which is what I started talking about at the start of this video. So yeah, and then transaction details. So what I did there was I just specified an actual amount, which if we go back to the code, you'll remember. Wrong one. There we go. So we go back to code. Where was it? Amount. Yeah. So I've put 1,000, whereas they put add recipient and then they put faucet address. So that's who you're sending it to, and that's the amount. So I kept the faucet address the same. So, yeah, one other difference. So in their example, they use faucet address dot script pub key. I had an error, so I had to put in faucet address dot payload dot script pub key. If anyone knows about that or cares to comment, that would be interesting. So that's it for now. I'm not going to waffle. I'm still learning this. The next part of my evil plan is to integrate this with Axum. I've had a go already, but effectively ended up with creating one endpoint, which was getting the balance. Next, I need to add another endpoint, which creates the transaction. I don't know if anyone can comment whether I need to create an endpoint to create the transaction, and I think I will probably have to do these 3 steps within one function, and that will be a second endpoint. So I'd have one endpoint to check balance, and then I'd have another endpoint to so actually create wallet should be default, and then I'd have one endpoint to get the balance, check the balance, if the user wants to query the balance, and then I probably need another endpoint which I pass in a parameter of the amount to send in a transaction, and I will need a parameter. So I've hard coded a lot at the moment, so yeah, I'll need to start going in and putting variables and using. So with Axum, you have the path object, which not path, the path. It's a type which comes free with Axum, so it enables you to extract a parameter from the path. I've covered that I started to look at that in the previous video. So yeah, thanks for watching. I'm learning this, so please don't take any of this as gospel, but I just wanted to show just the difference between what I've done and the documentation. So, and also just kind of show you that the testnet is there to use and to get your hands dirty with. So yeah, thanks for watching. I'll be back soon. Thank you. Subscribe, thumbs up as well. Yeah, thanks.